Story problems, resolving vectors. I'm going to, in this 5-problem set, do the odd number problems 1, 3, and 5. And as always, I invite the viewer to try to work out the problems in advance and then go ahead and play ahead to see if you got it right. So this says, draw a picture and solve each problem. We have a glider floating through the sky at 45 miles per hour with a heading of 50 degrees north of west. When it meets a headwind of 10 miles per hour, blowing 45 degrees south of east. What is the resultant velocity? So for this, what I like to do is just draw a northeast, southwest coordinate grid. And so what you're going to have is north is going to be the top, and to the left is going to be west, east is to the right, and finally south is downward. And it says we have a glider floating through the sky at 45 miles per hour with a heading 50 degrees north of west. And so you go to the west and rotate 50 degrees north of that. So I'm going to go ahead and get a blue vector, and this is going to be a vector. And so I draw this. This has a magnitude of 45 miles per hour. And what we have is 50 degrees north of west. That's going to be our reference angle right here. So there we have that. And that says meets a headwind of 10 miles per hour blowing 45 degrees south of east. So I'm going to take this red one here, and I'm going to go 45 degrees south of east will be just equidistant between south and east. So here it is. I'm going to make it just a little bit shorter. So this is going to be 10 miles per hour. And this one's going to be a 45-degree angle. That's our reference angle. And you can see that they're almost lined up. And they wouldn't be, but looks like they're about 5 degrees off. And so if these were perfectly aligned, which they are not because of the degree difference, we would actually have 45 miles per hour minus 10 miles an hour, so perfect 35 miles per hour, but it's going to be a little different than that since the angle is a little bit off. Now, one thing we can do with these reference angles is to make vectors out of them. We can use the signs of a reference angle, but I find that the easy way to go is to use standard positioning for angles. So this 50-degree reference angle is going to, 50 degrees is the complement, rather supplement to the standard position angle, which is going to be 130 degrees. How do you get 130 degrees? Well, that's going to be 180 minus 50. So that's going to be our standard position angle. And so for this vector, what we have here is 45. 45. We have cosine of 130 degrees. And then comma, we have 45 sine 130 degrees. So that's going to represent our glider vector. And now we go to this other one, this headwind. And what we have for this one is in standard position, we're going to have this type of rotation like this. And that's going to be 360 degrees minus 45, or 315 degrees in standard position. And so I'm going to go ahead and just right underneath here put 10 cosine, that's going to be 315 degrees, and then comma 10 sine 315 degrees. That's the beauty of using standard position angles, because what you're going to do is get it exactly right. So now we can just go to our calculator. Now the calculator, I see we're in radians, and so we're going to need to change that to degrees. So I go to mode and go down to degrees. And so what we have is we have 45 cosine of 130 degrees, and that's going to be plus 10 cosine 315 degrees. And so we have that, and that's going to give us our component there. So negative 21.854, we'll say negative 21.854, comma. Now we're going to find our other one here. So we go to 45 sine 130 degrees plus 10 sine 350 degrees. And so for that we get 27.401, we'll say 27.401. And I expect we're going to see almost 35 miles per hour, but for magnitude, but we'll just have to see. If what we do is we're going to take our magnitude is what we're looking for, speed, and we're taking the square root of this negative 21.854, and we're squaring that plus this 27.401. We square that. So let's go to our calculator. And I think we should get a little less than 35 miles per hour if it's right the way I think it is. So second, so we're going to take this negative 21.854, square it. Now one thing you can do, it's going to be positive, so you can just put the without the parentheses, you can put the positive and square it. That would take care of it too. Plus, and what I'm going to do for the next one is I'm going to do second answer, just because I have the last thing calculated. So I'm going to press second ANS and square that, and so we're going to have 35.049, so a little greater, 35.049 miles per hour. And then for direction, it doesn't say direction here, but our direction, we have to look at which quadrant we're in. And we're going to be in this quadrant 2, so it's going to be 180 degrees. And how do I know that? Because we have, if we stack these vectors together, we're going to be in quadrant 2 right there, so that's what it's going to look like. So we use 180 degrees plus inverse tangent of, we have y over x, so it would be 27.401 over negative 21.854. So that's going to be, we'll get a standard position angle on that guy. So we have 180 plus inverse tangent. There it is. We have this y over x. We take this 27.401 divided by this negative 21.854. I hope you're comfortable working with these standard position angles. It just make your life easier. You know how to do that. So we get a direction of 128.575 degrees. And so what that does, that's going to be a standard position angle. So it's going to be it's just going to be a little bit to the right. In fact, I'll just trace it in purple. It's going to be just a little bit to the right of this other one here, like this. So less magnitude, and just rotate it ever so slightly that way. That's what the path's going to look like. Okay, let's go ahead to the next automata problem we're going to look at, which is number 3. We have a ship leaves port and sails 14 miles at 68 degrees south of west. Well, I'm going to go ahead and just draw a directional grid like this, just like we did in problem 1. So we have the same thing here. We got north up here, we got west to the left, we got east to the right, and finally south and downward. And the ship leaves port and sails 14 miles at 68 degrees south of west. And so it's like you're going south, and south of west is like, it tells you the reference angle is 68 degrees south of west. So I'm going to draw this right down here. So this is going to be 14, as in 14 miles, and that's going to be our reference angle, 68 degrees. Now, again, we can standard positionize this thing already. If we take 68 plus 180, we would standard positionize that angle, which is going to make our life easier. So that's going to be let's see, 248 degrees, right? That's 248 degrees in standard position. And next it says, then the ship turns due east and sails 8 miles. And so we go like this, 8 miles. And I'm going to go ahead and so 8 miles due east right here. So that's going to be 0 degrees, right? So that's going to be, because that's exactly the initial side, which is the same thing. So that's going to be 8 miles. So we have down here 14 miles and then 8 miles, and so the composite of those two is going to get us where we need to go. So it would be effectively taking this vector right here, if I can get it going, yeah, right here, and it would be where we end up, and it will give us a direction to go back. So let's put this right back here. So again, we could set it up just like we did for problem 1. So we take our 14-mile one here. So we got, open it up like this. We have 14 cosine 248 degrees, comma 14 sine 248 degrees. And then what we're going to have is, for this other one, we have 8. And what angle are we looking at? 0 degrees. So we have cosine 0 degrees, which is actually 1. And then we have 8 sine 0 degrees, which is 0. So this one here, this is going to be the same as 8 comma 0. And I'm just putting that there because it'll make our calculation easier. So we have 14 cosine 248 degrees plus 8. I'm just going to put it here for 14 cosine 248 degrees plus 8. So that's going to be 2.756. 2.756. So 2.756. And then the next one we have is we have 14 sine 248 plus 0. So 14 sine 248 plus 0, just be 14 sine 240. So I have negative 12.981 looks like. And so that's going to be our component form of the vector, and so our how far away, that's going to be the magnitude. So it's like we're taking this thing right here, bring it over here, yeah, bring it right over here like this, and then going back home, it's going to be this vector, shortest way home to port. How far is it from port? We just go straight back to the origin like this. That's the answer we're looking, the magnitude of that purple vector, and then now analyze the direction of it. So for this one, our magnitude is going to be the distance away, which is going to be this 2.756 squared plus we have this negative 12.981 squared, and that's going to be our magnitude, the distance away, and how far the ship is from port. So let's go to our calculator. Okay, we get this. We have 2.756. We'll put down 2.756 756. That's positive, so I don't need parentheses for that. And we have plus, and again, this is going to be positive, so I'm just not going to put the negative sign there. Well, I guess I will, because I'm just going to paste it. I got to do that. I'm going to do second ANS. So we have that, and I know that's negative, so I have to have a parentheses there to make it right. So we have that, and we have as our answer 13.2. Looks like 13.270. So 13.270 miles from port. Away, we'll call that. Okay, so that's going to be one of our answers. And that says what heading would be the shortest way home. So we're looking at the direction here. And the thing about it is it looks like we have cosine positive and sine negative, so we're talking about a quadrant 4 deal. Now it looks here in my drawing, it looks like it's quadrant 3 business, but because of the cosine and the sine, cosine being positive, sine negative, we know that's a quadrant 4. So our direction is going to be equal to 360 degrees plus the inverse tangent of y over x. We have negative 12.981 over 2.756. So we'll get what that is here shortly. So we have 360 plus inverse tangent of, we have sine over cos. Let me make sure. I want to don't want to get this wrong. So negative 12.981. So negative 12.981 over, that's going to be 2.756. And that should give it, so domain, something happened here. What did I do? Oh, inverse, I put inverse sine. Okay, let's get inverse tangent like we were supposed to. Plus, there, we should be better now. Negative 12.981 divided by 2.756. It's a good thing I got an error message. I might have got it wrong. That's going to be 281.986 degrees. So 281.986 degrees. So that's going to be the direction. So 281 point, it's going to be, it would be here, because that's 270 going straight down. So thing's going to be right here. It says what heading would be the shortest way home. Well, that's the direction of the vector. And so you actually have to go the opposite way to go home. So it's pointed down here. So you got to take that one right here, and you got to subtract 180 degrees to get the direction headed home. You see that because you got to go the opposite direction. So you take minus 180. So one thing you have to do is you have to think what's being asked here. So 101.986. So that's going to be, going back this way is going to be 101.986. And you can see if you take this thing to the origin, see, that's going to be 101.986. Let me go ahead and just write that. It's going to be, yeah, that's going to be that angle there, this angle here, I'll just write here, 101.986 degrees. Okay, that's what you have to go home to get to the origin. So 101.986 degrees. Okay, And so we have our magnitude. Great, we are in good shape there. Okay, let's go on to problem number 5, the last one we'll look at here. Okay, we have a swimmer that is starting out swimming a steady 2 miles per hour, 30 degrees south of west. So I'm going to take the same thing we've been doing on 1 and 3, just getting our little XY coordinate plane, a northeast southwest arrangement. Here's north up here. We have west over to the left, east to the right, and south down. And so we're swimming 2 miles per hour at 30 degrees south of west. So we take, that's going to be 2 miles per hour is 30 degrees south of west. So there's 2 miles per hour. I'm going to call it 2 miles per hour. And this is going to be 30 degrees right here. And so what we have here is, and I know what sine and cosine of 30 degrees is, so that's going to be helpful. But standard positionizing this angle here, we go like this. We would add 180 to that, and we would get 210 degrees, standard position the angle. Next it says 5 mile per hour current is flowing at 10 degrees north of east. And so starting right here, I'm going to put, it's going to be 5, so it's going to be quite a bit bigger than that 2. So it'll be out here like this, something like this. Okay, so it's going to be 5 miles per hour, and that's going to be 10 degrees. That's going to be north of east. So in quadrant 1 here, the standard position angle is the same as the original, so we can just put things together right now. So our resultant vector is going to be, well actually we're going to have, for the swimmer swimming, and you can kind of see that this current direction is going to overpower the direction of that swimmer. So the swimmer is going to be going to the like west southwest, but it's going to be overwhelmed. It's going to end up being over here in quadrant 1 just due to the force of the current actually happens. So we have 2 cosine of 210 degrees, standard positionizing that angle, and then we have 2 sine 210 degrees, and then we're going to add to that our current vector, which is 5 cosine 10 degrees, comma 5 sine 10 degrees. So we go ahead and add that up. Let's get to our calculator. So we have 2 cosine 210 degrees, and I know that's going to be negative square root of 3 over 2 because that's a 30 degree angle but in that direction. So we're going to have and actually plus 5 cosine 10 degrees. So we have that. So we're going to have 3.192. So 3.192, comma, and we come here and we're going to put 2 sine of 210 degrees plus 5 sine 10 degrees. And for that we get negative 0.132, we'll call it negative 0.132. So that actually, what that means is the thing is going to end up here in quadrant 4 barely, because that cosine is positive and sine negative. So that's going to you're going to end up right over. It's going to look something like this. Is what it's going to look like. I'm drawing it in purple. I don't know if it looks exactly like that. We can find our magnitude, right? So our magnitude is going to be this this 3.192 squared plus, and this is a very small decimal number, so it's not going to be affected much at all, 132 squared. So we're going to get, let's get this right here, control square root, we get 3.192, square it, plus, we'll put, oh, I don't want that. Let's see, let's go parentheses, and then we'll do second A and S to get that negative 0.131, and square it. So we get 3.195 miles per hour. And so it's also the speed in the opposite direction, kind of where the swimmer is originally headed. In fact, it's going to be bigger than that 2 miles per hour vector. So it's going to be out here like this, kind of. I'm drawing it. That's what it's going to look like. And the direction, we're in quadrant 4, so it's going to be 360 degrees plus the inverse tangent of our y over x. So we're going to have our negative 0.132 over this 3.192. That's what it's going to look like. So we get to our calculator. We put 360 plus inverse tangent of y over x. Let me see if I got it right. It should be our negative 1 point. Make sure I got this right here. Yeah, negative 0.132. So negative 0.132 over, we have our 3.192. I think that's what it is. Let me take a look here. 3.192. Yeah, it is. And the calculator gives us 357.632. 357.632. Okay, so it's going to be just this angle almost as I drew it. So this is going to be, let me draw it here. So this right here is going to be 357.632. And one way you can do that is you could say that's going to be, if you subtract 360, one way of saying it, it'll be 2.368 degrees south of east. See that? So it'll be 2.368 degrees south of east in reference angle. So anyway, that's it. Those are all the odd numbered ones. I hope this has been helpful to you. Again, this really, to me, demonstrates the power of standard positioning for the angles. Good luck, and thanks for viewing.